Autonomous character scene interaction synthesis from text instruction. In this work, we tackle the exciting challenge of generating scene-aware interaction motions for virtual characters based on text instructions and target locations within a 3D environment. What you see here are motion generation results from our method in a novel scene, leveraging interactions learned during training. By providing intuitive text instructions, users can direct the virtual character to navigate the scene and interact with objects in a natural and contextually appropriate manner. Our proposed dataset used for training will be introduced in the final segment of this video. Our motion generation method handles both locomotion and interaction motions. For locomotion, users can specify the target location, provide textual guidance, or define a trajectory for the character to follow. The method also addresses interaction motions, including interactions with static scene objects, hand approaching motions, and manipulating objects held in the character's hand. To tackle complex instructions, we incorporate foundation models that break down the initial instruction into manageable sub-instructions. Our method is an auto-regressive conditional diffusion model that takes language guidance, the goal location for the current segment, and the scene voxel as input. Human motion is represented as a sequence of body joint locations. To ensure continuity between motion segments, the last 2 frames of the previous segment are copied to the beginning of the current segment. We employ a transformer encoder as the U-net of diffusion, where each conditional term and each frame of motion occupies a single token. The number of frames that have been generated is incorporated in the text embedding for information about motion progress. The output of the model is the joint locations of the next motion segment. Additionally, we train a scheduler to predict when the current motion should be concluded and the system should proceed to the next sub-instruction. The character's scene awareness comes from a local occupancy grid. Each voxel in the grid indicates whether the corresponding location is occupied by a scene object. Additionally, we employ another occupancy grid at the expected goal location of the current motion segment. For locomotion, this goal location represents the place the character needs to reach, while for interaction motions, it represents the location of the object with which the character is interacting. The local occupancy grid continues to take effect during interaction motion. Here are some more examples. Our approach introduces variability in the generated motions, allowing for multiple plausible interpretations of a single instruction. In the comparison section, we evaluate our method against previous work. Given the same trajectory and scene, the baseline method generates motions that penetrate scene objects, and the character walks as if there are no obstacles present. In contrast, our approach generates characters that actively avoid penetrating the scene and exhibit natural cues of scene awareness. In this example, the character lowers the speed and looks at the ground when navigating through the environment. Here are some more comparison examples. Here we showcase our method's ability to generate motions that seamlessly transition between different instructions. Even when the character's actions are interrupted by a change in instructions, the resulting motion remains plausible. This feature allows for dynamic and responsive character behavior. In addition to our motion generation method, we also introduce a comprehensive motion capture dataset called Lingo. To create Lingo, we employ a synthetic vision approach, where interactive objects, both static and dynamic, are projected into virtual scenes displayed in a VR headset worn by the motion actor. Lingo comprises 16 hours of motion sequences in 120 indoor scenes covering 20 types of interactions, each annotated with precise language descriptions. Lingo includes extensive sequences of locomotion within scenes, featuring natural collision avoidance and target-driven walking patterns. With more than 20 interaction categories, Lingo covers a wide array of common activities in everyday life with rich text annotations, making it a comprehensive resource for potential applications. Our motion generation method and Lingo dataset will be made publicly available to the research community.